A very good day to Anchi Mohammad Rashid Zakaria and also my dear friends. My name is Sivanesh Mayachandran 01DK820F2022 along with my teammates Kamaleshwaran Trivalselvan 01DK820F2007 and Lohindran Parameswaran 01DK820F2018. So we are from section DKA5A here to do a presentation video based on our mini project that we have been done for DCC 50203 Reinforced Concrete Design RCD. Moving on to our next slide, which is about the table of content which we'll be having in this video. So the very first one will be the introduction along with company profile, architectural drawing, spec of plan, elements, beam, slab, and finally column. So this specific part of beam, slab, column will be having their own calculation to retain a very good structure in order to retrieve a reinforced concrete design building. So now in this slide we able to see what is the meaning of reinforced concrete design. A problem unique to the design of reinforced concrete structures is the need to detail each member throughout. Steel structures in general require only the detailed design of connections. For concrete structures we must determine not only the area of longitudinal and lateral reinforcement required in each member, but also the way to best arrange and connect reinforced to ensure acceptable structural performance in between. This procedure can be made reasonably simple if that is not so easy. Purpose of this course is to establish a firm understanding of behavior in reinforced concrete structures, then need to develop method used in current practices and to achieve familiarity with codes and specification governing practical moments.
Okay. Hi to everyone. I am Lohindran Parameswaran. My registration number is 01DK20F2018. Today I am going to talk about company profile. The company we are choose for this our project design project is RS Master Builders Center in Bharat. Their registration number is 756219. The place will located of this company is 104 Persiaran Sungai Padi Timur 16, Taman Mas 30100 Ipoh Perak. And this slide I will attach the info and office of the facts of this company number. What is the RS Master Builders? The introduction of the RS Master Builders is the RS Master Builders Center Bharat can call be the RSMB, formerly known as the Fredgis Development. Fredgis is the director of this company. Wholly owned private limited company that was incorporated on 13 December 2006 under the Act of the 1965 with CIDB G7 license. Of course, business is providing professional construction to the industry at large. RSMB is also member of Persatuan Contractor India Malaysia, that is called PKIM, and the Welfare Association of the Ipoh Contract Workers. RSP has the expertise and experience of our knowledgeable servicemen who have been involved in construction and PlayStation business for many years can be utilized to upgrade and to fulfill the demands of today's construction requirements. At the same time, that need to have a higher level of construction service to increase the risk, require us to continuously improve our construction and platform system. And then I will attach the certificates of the company. Next, this is a certificate of the company. The first one is SSM. This is the SMM. And the CIDB certificate. This is the company CIDB certificate. And CIDB score. This is the CIDB score. And then certificate of the achievement. The certificate of achievement, they will get, this is the company of RSB will get a first star for their project. Okay, for more details, we are included all these details about company profile, and moreover, we are included in project report.
Okay, very good day to my lecturer and my fellow friends. Before I start my presentation, I would like to introduce myself. I'm Kamaleshwaran, son of Trivalselvan, and my registration number is 01DK820F2007. Okay, now I'm going to explain about the vision and mission of RS Company Builders. Okay, for the vision is at RSMB, we believe in giving the best service to our clients with the most reliable construction personnel and supervisions. Our staff undergo compulsory training exercise to equip them with the necessary knowledge of construction administration, crisis management, security reporting, emergency handling, and public relations. It is our policy that well-trained construction personnel ensure the well-being of our valued clients. Okay, for the missions for the RS Builder is, since our clients' safety, peace of minds, and good construction quality are our foremost concerns, we regard and practices win-win situations with our clients as our mission statements. This has enabled relationships with our clients to develop into mutually prosperous partnership in today's challenging business environments.
Next, we able to see what is the architectural drawing is exactly executed by the authorities of our plan workers, and where it will be show about the plan of the shop lot that we have been chosen. The very first diagram which is showing the ground floor plan with the accurate of dimensions that have been given based on the plan, and the second figure is showing up the very first floor plan which is going to be executed with the shop lot progress, and the very last figure is showing about the roof plan on how it's going to be as the design with using the AutoCAD software. After that, in this slide we able to see two kind of figures that have been attached with this slide. The very first one will be the topographic plan, which is going to be executed with the entire of the plan of having the surrounded portions of the building, and the second figure also replicating about topographic plan, which is the lot number that we're going to be execute with the construction progress. After that, in this slide I'm able to attach with three kind of figures. The very first two figures is replicating on how the beam and columns plan it will be, and the very third figure is showing up how the staircase plan was planned initially by using the AutoCAD software. Next, I'm going to into the calculation for the specific part, which is beam. So here in this calculation, we able to see the ground floor plan and also first floor plans beam structural design on how it was reinforced with by using concrete. So what is a beam is replicating to? A beam is a structural element that primarily resists loads applied laterally to the beam's axis, which is mean to the element designed to carry primarily axial load will be able to strut or column. Its mode of deflection is primarily by bending. The loads applied to the beam result in reaction forces at the beam's support points. So this is what we could relate with the beam. So let's move on with the calculation part. So now let's get into the calculation for the beam. So here I would like to inform that the beam for ground floor and also first floor, I use the very same criteria of the contents for the beam structural. So here first I begin with the design data first. Okay, under the behind data we are having the dimensions. Under the dimension we are having five kind of criteria that we should be identified. The very first one will be total area of structure, which is identified as 47 meter times with 50 meter, which is going to be as the area that which is replicating about 47 and also 50 meters of the area. So now we're going to see about the slab thickness. Slab thickness is 150 millimeters, which is equals to 0.15 meter. When we want to convert millimeters to meter, we have to divide with the 1000. So now let's get into move with the beam size. Beam size is can be simplified as B times with H. So what is B? B's value will be 250 mm, according with the H is equals to 650 mm. So now we can see clearly on the column size, which is B times H also, we can simplify it, and also in terms of that we can identify 250 millimeter times with 250 millimeter, which is the square rectangular column that we are having. Now, what is the very last criteria under the dimensions will be column height. So the column height which is given is 4.00 millimeter of height in the plan accordingly. So now we're going to identify the actions. So we are having two kinds of actions. The very first one will be the permanent load and also action variable load, which is also known as QK and also GK. QK is standing for the variable load and also GK is standing for the permanent load. So we are having QK as 4.00 kilonewton per m quadrature, and also permanent load GK we are having 1.35 kilonewton m square. So these are two things that we have been identified, and then we are going to the material specifications. So under this material specification, we have to identify 6 kinds of criteria designs, which is design life, which is equals to 50 years, and also fire resistant has what we do know that for concrete is 1 hour basically, which is going to be the very constant one in every calculations. So the exposure classes for concrete design will be XC3, and unit weight of reinforced concrete that we have been used in this entire project will be 25 kilonewton m cube, and the characteristic strength of concrete, which is also known as FCK, is 30 newton millimeter square, and also characteristic strength of steel will be 500 newton millimeter square too. So now let's get into the beam calculation. Before this, I've been explained about design data. So now let's get into the beams calculation. So how are we going to identify the beam design? So first we're going to draw what is the imaginary of the AutoCAD drawing that we already have. So this is the whole draft that I've been draw, which is excluding about O until P section slash with 1 over 2, which is O until P 1 until 2. So this is going to be the beam that I'm going to having the specific calculation on towards is. So this is for the ground floor and also first floor. So the specification is design life is almost for 50 years. Fire resistance is 1 hour as per stated in the design data. Exposure class is X3X, and also unit weight of concrete is 25 kilonewton m cube. So then characteristic action as per I said in the previously, permanent action, which is also known as GK, is 1.35 kilonewton m square. Variable action QK is 4.00 kilonewton m square. So now we're going to see about two kind of materials that we have been added towards this beam specification, which is characteristic strength of concrete, which is also known as FCK, 30 newton mm square, and also characteristic strength of steel FYK, 500 newton millimeter square. So we was given a small information in the entire project that we have to assume the bar space as 10 millimeters, and also the slab thickness, the maximum thickness for the fire resistant will be 50 millimeters. So this could be the estimate thickness including all the deflection that we are having through this beam calculation. So now let us move on to the next slide. Now, the very second thing that I'm going to be explain on you about is the durability, fire, bond, and also requirements. So for this, we would like to know what is the value of H. H is equals to height. Height is not given, but all the other information related to how to determine the height, which is equals to H, is given. So what is the formula that we're going to use will be H is equals to length need to be divided with 24. So our L will be 4.00, which is equal to 4000 millimeters. We need to be divided with the 24, which is going to be the very constant one, and this will be the formula. So the answer that we retained as the 167 millimeters. So when we want to use the code, we will be users of the 145 millimeters in order to retain the durability fire bond requirements. And now we have to identify the minimum cover with regard to bond, which is also known as in unit C min D, which is equals to 10 millimeters as per stated in the drawing. And also the specifications also able to explain about minimum cover with regard durability, which is C min dur, which is equals to 20 millimeters. So next will be minimum required exit distance for 1 meter for fire resistant will be conclude as A is equals to 20 millimeters as per given, or even we also not given, we also can be able to calculate what is the actual value that we will be get for the A. So now we're going to be calculate what is the minimum cover with regard to fire. So what is the C min? C min value is the most adhere to determine what is the C norm. Okay, so our main task will be to identify the C norm. So in order to find the C norm, we have to make sure C min all need to be in order accordingly correct in form. So the very first one will be A minus with bar need to be divided with 2. So our A will be, we have to identify as 20. So we're going to be use the bar as 10. So the 10 need to be divided with 2 because it's a formula. So 10 need to be divided with 2, we will be get 5, and 20. 20 need to be minus with 5, we will be able to get 15 millimeters in order. So this will be explained about the allowance in design for deviation, which is CDEF is equals to 10 millimeters. See, this is what we can able to relate with this C norm. So what is the method to find out the C norm will be? We are having a specific formula which is C min into B plus with C def. So 20 need to be plus with 10 because we already find previously. We will be get 30 millimeters in order. So we have to use this of C norm as 30 millimeters. So this is our final answer for C norm will be 30 millimeters. So now let's get into move into the slab self weight. So how to determine the slab self weight will be given that 175 millimeter previously. So why I wrote 0.175 here, it will be, it is should be in meter form. When you want to convert, it should be in meter form. Need to be times with the unit weight of the concrete, which is 25. So is equivalent to 4.38 kilonewton m square. So now we can able to see the permanent load, which is also known as GK. Previously we could understand that 1.35 kilonewton m square, and be able to characterize two characteristics of permanent load, which is also known as GK, and also the variable load, which is QK. For GK we know that 5.73 and also QK 4.00 kilonewton MQ. So now we're going to identify what the design load. So design load will be equivalent to ND as unit. So we're going to use a specific formula at here, which will be 1.35 GK plus with 1.5 QK, which is equivalent to 13.7 kilonewton m square, which is able to relate with all the requirements that have been given through in this double story plan of building by the authorities. So as what we can conclude is 1 meter width, which is equivalent to VD is equivalent to NDX per M is equivalent to 13.7 kilonewton meter. So this is on how we have to identify the durability, fire and also bond requirements. So now we're going to move on to the slightly the diagram sketchments, which is having three kind of things. The very first one will be itself of the self weight, and also we are having the shear force diagram and also bending moment diagram. On how to find the shear force diagram, it is very easy to identify because it will be using the specific formula as V is equals to WDL need to be divided with 2. This is the formula that we'll be using for every kind of shear force things to identify in a diagram given. And also it is able to relate with 27.4 kilonewton meter. And also bending moment, also we are having the specific formula as well. M is equals to WDL square need to be divided with 8. So what we will get is the same one as per with the shear force. We can see that, which is 27.4 kilonewton meter per mm. So here we're going to move on with the main reinforcement. And how what is going to be the main reinforcement is the installation of steel bars that we're going to be get into towards these beams. So we're going to firstly identify what is the effective depth. So to find the effective depth, we'll be using the specific formula, which is D is equals to H need to be minus with C norm, which we have identified previously, and need to be minus with 0.5 of area of bar. So now we're going to be 175 will be the H, need to be minus with C norm, which is equivalent to 20, and need to be minus with the 5. So what will be get is 140 millimeter in order for the effective depth. So now we're going to see the what is the bending moment, which is also known as in unit of MED, is equal to 27.4 kilonewton meter. So how we got this will be from the diagram that we have been sketched previously on this step. So we're going to be use this formula in identify the bending moment, and what will we get is 0.04, which is lower than K balance, which is 0.167 in standard. So it will be singly, which is the compression reinforcement is not required for this specific part. So now we're going to identify what is the Z. So the Z will be using another kind of formula, which is able to see Z is equals to D need to be times with 0.75 root of 0.25 need to be minus with K over 1.134, which is usually be lower than or equivalent to 0.95 D. So what we able to get after the identification is Z is equals to 133 millimeters after the calculation. And we're going to find what is the AS. So we will be using the specific formula for identify the AS2, which is AS is equals to M over 0.87 FYKZ. So the answer we will be get is 474 millimeters square per M. So let's all move on to the next thing, which is able to find out the minimum and also maximum reinforcement area. So the very first step will be AS mean. How to determine the AS mean will be the given formula as 0.26 need to be times with F atmosphere over Fyk need to be times with BD. So the answer that we will be get after the calculation, after install this formula into this calculation, will be 189 millimeters square over M. So now we're going to identify the AS maximum, which is we're going to use a specific formula which is 0.04 AC, which is equivalent to 0.04 need to be times with 1000 need to be times with 175. We will be able to get 7000 millimeters square over M. So what we can determine from here is we have to use the main bus and also secondary bus. What is the main bar we can able to use is equal to H10 is equals to 150, which is the exact value will be 524 millimeters square over M. And also the secondary bar is also can conclude as H10 is equals to 300, and also the exact value will be 282 millimeters square over M. So this will be the minimum and also maximum reinforcement area that needed for this particular of shop lots that we're going to design out for the specific beam for ground floor and also very first floor. And we're going to find out the shear force. How to determine the shear force will be design and shear force is equals to as unit VED. So what we were able to get is 27.4 kilonewton. Previously we got in the sketchment of the diagram. And also design shear for resistance VRD C is equals to, we're going to use a specific formula. After that, we'll be able to get an answer 2.20, which is more than or equal to 2.0. So as what we can conclude is, if it is above the boundary, it is above the limit, we have to use 2.0 compulsorily. So we will be get the answer as 2.0 for the VRDC. So we're going to find for the P1 will be using the specific formula AS over BD should be lower than or equivalent to 0.02. So the answer after we having the solving calculation will be get to 0.004, which is lower than or equal to 0.02. So that is the value for P prime. And VRDC, we're going to use a specific formula, and after the installation of the numbers into the formula, it will be replicated as 0.12 need to be times with 2 times with 100 times with 0.004 times with 30 power of 1 over 3 need to be times with the whole answer with 1000 times with the 140. So what we able to get will be 78.9 kilonewton. That will be the answer for our VRDC. So now we can able to see what is the V mean. So V mean we will be using the specific formula 2, which is 0.035k power of 3 over 2 FCK power of 1 over 2 BD. So we're going to be install each and every calculation number into this formula, which is also can replace and also represent at 0.035 need to be times with 2 power of 3 over 2 times with 30 power of 1 over 2. So the answer we'll be able to get for VRDC will be 76.9 kilonewton, which is more than VED, which is the statement can be concluded as okay. So that is for the part of shear. And now we can move on to the next part of the calculation, which could be the last part, deflection. So deflection, we are having the percentage of required tension reinforcement, and where we're going to use P is equals to AS required or need to be times with or divide with BD, which is 474 need to be divided with 1000 times with 140. We will be able to get 0.0834 as for the percentage of required tension reinforcement. Now we're going to see about the second one, which is reference reinforcement, which is going to be as a unit to follow, and also we have to require for a reference for the reinforcement values, which is PO is equals to FCK power of 1 over 2 times with times of power of -3. So we were able to get 0.0055 for this reference reinforcement point. And then the factor for structural system will be K, identified as K unit, which is equal to 1.0. So here we can conclude that P prime is need to be smaller than PO, should be used in equation 1 previously. So now we're going to be use the deflection method too, but we're having the another formula, which is we're going to use, and also the unit after we have the installation of the numbers, we'll be able to get 1 need to be in bracket of 11 plus with 1.5 root of 30 need to be divided with by 0.0055 divide with 0.0034 plus with 3.24 per root of 30 times with 0.0055 over 0.0034 need to be minus with power of 3 over 2. See, this is quite big calculation, and we're going to break it off the calculation to get separately counted, and also we have to identify and also combine is, and we have to get the 32.80 as a unit. And now we can able to see modification factor for spam lesser than 7 meter we can consume as 1.0, and then modification factor for steel area provided as per in the plan was given was AP need to be divided with A request, which is 524 need to be divided with 474. The answer we were able to get will be 1.11, and therefore allowable span effective depth will be, the unit will be used is L over D allowable is equivalent to 32.80 times with 1.0 times with 1.11, and the answer we got, we're going to be compared for the actual span effective depth, which is we are using the same kind of formula L over D for the actual, which we're able to get 4000 need to be divided with 140. So what we're able to conclude is L over D the actual will be lower than L over D the allowable. So this is the part for until the deflection, and now let's move on to the next entire calculation. Now in this slide, we're able to see the very last part of this calculation for the specific beam from the entire project, and also we are having the ground floor and also first floor beam calculation. So for the specific one, for the cracking we have to use and also the specific identification as H is equals to 175 millimeters. So the 175 millimeters is lower than 200 millimeters as for reference guide for cracking. So we are having used the main bar and also the secondary bar. For main bar we will be have the X max slabs, which is equals to 3H need to be lower than or equal to 400. This could be the reference idea also, which is equal to 400 millimeter based on our calculation. Maximum bar spacing, if we have to refer in the book, will be get 150 mm, which is lower than or equal to SMX slabs, which is considered need to be okay from this statement for main bar. For secondary bar, it's also the statement was acceptable at where it was required as okay, because mud slabs is equal to 3.5 H, which will be the formula, which is going to be the benchmark of us. We need to be lower than 450 or equivalent to 450, which is equal to 450 millimeters. So the max bar spacing will be 300 millimeters, at where it should be smaller than S max slabs, which is the statement was okay. So in detailing, we able to see the slab was draw, and also the x-axis is equivalent to 4000 millimeters, which is equivalent to 4.0 meters, and also the steel bar that we have to use is H10 is dash with 0.2 300. So we also can see the plan view, and also the concrete cover, which is equivalent to 30 millimeters, have been used in the below diagram that have been drawn. Now let us move on to the slab calculation for the ground floor plan and also attached with the first floor plan. Now I'm going to teach on how to calculate one way slab that we got in our plan for ground floor separately with the first floor. So first we're going to identify what is the slab design for us that we got. So here I'm attached also drill based on the drawings that we got. So this will be the slab plan, so which is 6400 of y-axis horizontal, and also the vertical will be 3000 in order. So here we can clearly see j until k, it is going to be a section that we're going to calculate specifically, and also 3 until 4. So this is the slab that one way replicating to calculate on more about. So first, what is the step is going to be identified with the long span versus short span. Long span is unit by Ly, short span was unit by Lx. So the longer one will be Ly, which is equivalent to 6400, the horizontal axis, and also the short span, which is Lx, the vertical axis, is equals to 3000 millimeters. So now we're going to detect what is the point that we got by using the specific formula, which is Ly need to be divided with Lx. So our Ly will be 6400, need to be divided with our Lx will be 3000. So the answer we got is 2.13, which is need to be considered as one-way slab in order to refer for this specific one-way slab. So the characteristics action has two I before say, which we got 5 elements. The very first one will be the permanent, also known as GK, variable, which is also known as QK. So our GK will be 1.35 kilonewton meter cube, which is excluding self weight. Variable QK will be 4.0 kilonewton over m square. Design life will be 50 years. Fire resistance will be 1 hour for this specific concrete design, and exposure classes will be XC3. So now we're going to identify what is the characteristics for the materials. So we got with 3 kind of formulas, and also the unit of ideas that we want to appear with. Characteristic strength of concrete FCK, also known as FCK, is equivalent to 30 Newton millimeter square. And then characteristic strength of steel FYK is equivalent to 500 Newton over mm square. Unit weight of reinforced concrete will be 25 kilonewton m square. So this is what we can identify for the materials for one-way slab for ground floor and also very first floor. The same thing will be applied to the ground floor and also first floor for one-way slab specifically. So it was given in the idea of the drawing that the assumed bar will be 10 millimeters. So we're going to identify the next step, which is the slab thickness. On how to find the slab thickness will be minimum thickness for the fire resistant will be 80 millimeter as per given into the code of the book, which is the reinforced concrete design book. And then we have to estimate thickness considering deflection for control, which is equivalent to n is equivalent to, we have to use a specific formula, and after we fill in with the numbers, we will be appear at 3000 over 25. What is the 3000 is mean to will be the vertical axis unit in millimeters, and also need to be divided with 25, which is unit weight of concrete, which is the base one, which is equal to 120 millimeters as per required for slab thickness. Now we can look into the actions. So it was the same thing that have been conveyed, which is we also identify the design actions. Design action, the specific formula will be 1.35 GK need to be plus with 1.5 QK. So the answer we'll be able to get is 11.87 kilonewton meter square. So now we're going to see what is the durability, fire and bond requirements. So we got the minimum cover with regard to bond, which is C min B is equals to 10 millimeters, and then minimum cover with regard to durability, C min dur is equivalent to 25 millimeters. Minimum required access distance for R60 fire resistance will be need to be considered as A equals to 20 millimeters, because we have been given in the plan as in a small words at the front of the outer cut design is A is equals to 20 millimeters that we should use. Minimum concrete cover with regard to the fire will be C min is equals to B need to be minus with bar over 2. So what is the answer? It will be 15 millimeters. So the for nominal cover, how to determine is C norm is equals to C min is equals to C def. So this is a specific formula that we're going to use in order to find the nominal cover. So 15 millimeters times with plus with 10 millimeters, we able to get 25 millimeters. So use C norm as 26 millimeter for an easier way in order to determine the another upcoming steps. But now we're going to do the analysis part. The very first one will be continuous one-way slab. How we're going to use this area of calculation. So area of the bay will be 6.4 meters. It will be times with 3.0 meters. So this is going to be the area of slab. So the area of slab is going to be completely include all over these places on this specific surface, and we're going to find out GK need to be divided with QK. So 4.0 need to be bahagi dengan 4.35, and we'll be able to get 0.92, which is equivalent to 0.92 lower than 1.25. QK is equivalent to 4.0, which is lower than 5.0 kilonewton m square. So it should be considered as 1 meter width of slab is lower than 5.0 kilonewton meter square. So now what we're going to do, the next step will be we have to draw the diagrams for replicating three results, which is the effective length, upcoming with the shear force diagram and also bending moment diagram. So here we can see clearly that it has been stated based on the reinforced concrete design book, we will be able to get what is the thing at here will be 0.6 FL, and also here will be 0.5 FL as the reference point. So for the bending moment it will be different, at best 0.086 FL, at the peak same goes to here, which is 0.063 FL, and also the bending moment at the lower peak will be 0.03 FL2. So the W that we are having for the effective length will be 11.87 kilonewton meter. So now we're going to calculate the F. The F is equivalent to WL, so is equal to 11.87 into B times with 3.0 meter that we got. So 35.61 kilonewton, it will be the answer for F to identify. And the main reinforcement will be the next part that I'm going to be explaining on this about effective depth. So the effective depth unit will be D. So D is equivalent to the specific formula. H need to be minus the C norm need to be minus the 0.5 bar 1. So here we're going to see 120 will be the height need to be minus with the C norm, which is equivalent to 26, and need to be minus with 0.5 need to be times with 10. So the answer will be got in total will be 89 millimeter in order. And then maximum and minimum reinforcement area. So we will be having two kinds of things that we identify, at where A as mean and also A as max. So A as mean will be using the specific formula as 0.26 in bracket FCTM over FYK need to be times with BD. So 0.26 need to be in bracket 2.9 over 500, and BD we are going to calculate. So 0.0015 BD is equivalent to 0.0015 times with in bracket 1000 times with 89 that we got previously. The answer as we got is 134 millimeter square over m. So what we can conclude is we have to detect the secondary bar. So use as follows of secondary bar is equals to h10 325 is equivalent to the exact value 242 millimeter square over m. So now we're going to see what is the ax max 0.004 c AC. So 0.04 times with 1000 times with 120 will be able to get 4800 millimeter square over m. So the next step will be at the very first interior support. So we're going to identify m is equal to 0.0086 FL. So how are we going to insert the values? 0.086 times with 11.87 times with 3.0, we will be able to get 6.73 kilonewton meter over m. So now we're going to find out two kind of things, K and also Z. So how to find the K? It will be MED over BT power of 2 FCK. So how are we going to insert all the numbers? So 6.73 times with 10 power of 3 need to be divided with in bracket 1000 times with 89 power of 2 times with 30. So 0.028 will be the exact answer, and it is lower than K balance. So 0.1767 will be the K balance reference point. So at where this could be the singly compression reinforcement not required, that statement that we can write for it. So now we're going to be identify the Z. So the Z value that we got is 183 millimeter cube over m. So here we can conclude and also write as use is H10 325. The exact value will be 242 millimeter square over m. So at interior support as follows. So m is equals to 0.03 FL. So 0.063 times with 11.87, it will be times with 3.0 meter. So we will be get 2.24 kilonewton meter is equals to over m. So AS equals to m over 0.87 FYZ. It will be shown as the answer for 61 millimeter square over m. So here we can use H10 375 for 209 millimeter square over m as the exact value. So the last step will be shear force determination. Maximum design shear force BED is equals to 0.6 F, that is the formula. So 0.6 need to be times with 11.85 as our F. So answer they will get is 7.12 kilonewton. And design shear resistance will be RDSC, which is 0.12. It will be K times with the 100 PFCK. Power of 1 over 3 need to be times with 1 BD. So the answer we got is 1.37, which is lower than or equivalent to 2.0. So we able to see what is the next step is about. Here we have been identified the VRDC. After all the calculation, we able to get 29.39 kilonewton, which is more than VED. So the statement that we have been run out from this exact idea will be the statement is okay. So now we're going to see what is the deflection. So deflection is about the percentage of required tension reinforcement, which is P prime is equals to A as required over BD. So the A as required is 183 as we found earlier. It will be divided with 1000 times with 89. So the reinforcement area ratio will be PO is equal to FCK power of 1 over 2 need to be times with 10 power of negative 3. So the answer we able to get is 0.0054 after the calculation. For factor of a mutual structural system will be K is equal to 1.3. So the E should be lower than PO, and where we will be get 61.93 as the answer. The modification factor for the steel area provided will be AS prof over AS required. So the AS prof will be 242 need to be divide with A as required, which is 183, we were able to get 1.32, which is lower than or equivalent to 1.5. Therefore, allowable spawn effective depth ratio will be 51.75 after the detection, and actual span depth will be using L over D the actual. So actual will be 3.0 meter. We have to change into millimeters, 3000 over 89. So the answer we're able to get is 33.71, which is lower than L over D allowable. The statement that we can run off is okay. And then we're going to see about the cracking. Cracking, we able to get the main bar and also secondary bar in order. After all the detection, we also gather the information to continue with the detailing. So now it could be the detailing part at where I've been done with the slab detailing. So the width will be 3000 as per usual. So 3000 millimeter need to be converted in meter. We will be able to get 3.0 meters. So it's 6400 millimeters as for the horizontal or even vertical distance for 6400. So 6.4 meters in order. So we have been used the steel bars as H10 0 to 300 for top, because it was in the top when we have to write the diagram of shear force, and we are having 300T as a use of the H1001. So we're going to use 300 top of the steel bars in detail of having a very strong one-way slab in order for the ground floor and also first floor.
A very good day to our lecturer and my fellow friends. Before I start my presentation, allow me to introduce myself. I'm Kamleshwaran, son of Thirubal Selvan, and my registration number is 01DK820F2007. Okay, today now I'm going to explain about the two-way slab, which is that applied on this project. Okay, first I'm starting with the specification, which is characteristic action. The permanent load, which is GK, is 1.35 kilonewton per meter cubic, excluding the sulfate. The variable load is GK equal to 4.0 kilonewton per m cubic. Okay, the next is materials. Characteristic strength of concrete, which is FCK, is 30, and also the characteristic strength of steel, which is FYK, is 500 newton per millimeter power of 2, and the unit weight of concrete is 25 kilonewton per meter cubic. Okay, the next is about the design life is for 50 years, and also the fire resistance is 1 hour, and exposure closure is XC3, and also assume the alpha bar as 10 millimeter. Okay, now I'm moving to the loading distribution, which is Ly is equal to 3000 millimeter, and also Lx is equal to 3000 millimeter, and Ly per Lx, which is 3000 divided by 3000, is equal to 1.0, which is less than 2.0, to find out which type of slab are these. So in this case, the total that we get is 1.0, which is less than 2.0, so we can consider it as two-way slab. Okay, now I'm going to explain about the slab thickness. Minimum thickness for fire resistant is 80 millimeter, so you can try the height as 150 millimeter. Estimated thickness considering deflection control, n equal to 3000 divided by 25 equal to 120 mm. Okay, the next is actions. So you shall find the slab self weight as identified as 0.15 times with 25 equal to 3.75 kilonewton meter power of 2, and permanent load is excluding self weight is 1.35 kilonewton meter power of 2, and the characteristic permanent action, which is GK, 3.75 plus with 1.35 is equal to 5.10 kilonewton meter power of 2. And the next is characteristic variable action, which is QK, equal to 4.0 kilonewton per meter power of 2, and the design action, which is identified as ND, is equal to 1.35 GK plus 1.5 QK. So at the place of GK and QK, you should replace the value that you get at the actions. So 1.35 times with 5.10 plus 1.5 times with 4. So the total loading design action that you get is 12.89. Okay, now I'm moving to the durability, fire and bond requirements. Mean cover with regard to bond C mean be equal to 10 mm, and mean cover with regard to durability C mean equal to 25 mm, and mean recovered exit distance for R60 for fire resistant A equal to 10 mm, and mean cover with regard to fire C mean equal to 10 mm, which is 10 minus 10 per 2. And the allowance for in this design for deviations is equal to 10 mm, and also the nominal cover, which is the come out with the formula of C mean plus C diff, which is 25 plus 10 equal to 35 mm. Okay, now I'm moving to the analysis. So this is the case one, which is interior panels. So this is the drawing of the slab. Okay, now I'm moving to the short span, which is the mx(x1) is equal to 2.78 kilonewton meter per meter, and also the mx(x2) is equal to 0.031 times 12.89 times 3.0 power of 2, and the value that we get is 3.60 kilonewton m per m. So for the long span, the first value, which is mxy1, is equal to 0.024 times 12.89 times 3.0 power of 2 equal to 2.78, and also for the msy2 equal to 0.031 times 12.89 times 3.02 equal to 3.6 kilonewton meter per m. Okay, now I'm going to find about the main reinforcement, which is effective depth. The dx is comes out with the formula of h minus c norm minus 0.5 alpha bar equal to 150 minus 35 equal to 8 minus 0.5 times with 10. You will get as a dx as a 110 millimeter, and also dy is this h minus c norm minus 1.5 bar equal to 150 minus 35 minus 1.5 times is 10, and you will get the dy as a 100 millimeter. For the minimum and the maximum reinforcement area is as mean is 166 millimeter power of 2 per m, and also the as max is 6000 millimeter power of 2 per m. So the formula that used for as min is 0.2x bracket fctm per fyk close bracket times with bd. And for the ax max, the formula that used is 0.04 ac. Okay, for the try and error is h10 to 350, which is the value is 224 millimeter power of 2 per m, and for the h10 to 400 is the value that you're going to get is 196 millimeter power of 2 per m, and h10 to 4 to 5 the value is 185 millimeter power of 2 per m, and last but not least the h10 to 450 the value is 174 millimeter power of 2 per m. So for the secondary bar, we are going to use the h10 minus h10 to 450, which is the value is 174 millimeter power of 2 per m. So for the short span, Firstly, we're going to find out the midspan in short span. MSX is equal to 2.78. So the formula that we are going to find about the k. So for find the k, we are going to use the formula of m divided by bd power of 2 fck. So the m is as 2.78, which we will get in earlier steps, and also divided by 1000 times 110 power of 2 times with 30. So the value, the k that you will get is 0.0077. Here you can see the original value of k balance is 0.167. So the value that we get k, which is 0.007, is less than k balance. So the compression reinforcement is not required. So the next step is we are going to find the Z, which is going to use the formula of T bracket 0.5 punca quasi 0.25 minus K per 1.134. The answer that you will get, the Z that you will get, must be less than 0.95. So if you get the less than 0.95, you are going to use the value that you get. If it is bigger than 0.95, you will going to use the value of 0.95, which is the original value. Okay, the Z is equal to 0.99d, which is more than 0.95d. So we are going to use the original value of d, which is 0.95 times with 110, and you will get a value as 105 mm. So this is our Z value, and the AS that we will get is 61 millimeter power of 2 per m. So the formula that we are going to use is m divided by 0.87 fykz. Okay, for the try and error, h10 is equal to 350, which is the value is 224, and also h10 to 400, the value that we are going to use is 196. So by comparing these two values, we can use the h10 to 400, which is the value is 196 millimeter power of 2 per m. So for the support, which is k, we are get is 0.0099, which is less than k balance 0.164. So the compression reinforcement not required. So for the Z is that we will get is 0.95 and 0.99, which is more than 0.95. So we are going to use the original value 0.95 times it 1110 equal to 105 millimeter. For the AS is equal to 79 millimeter power of 2 per m. So this is the final step, which is we find out the AX. So since we can use the AS means as a 166 millimeter power of 2 m as a AS, because the trial section that we used is 196 millimeter power of 2 per m. So it still is enough for this trial section. For the long span, we should find the mid span first, which is MSY equal to 2.78. So the formula that we are going to use is K equal to M per BD power of 2 FCK. So the value that you will get is must be less than K balance. Original value is 0.167. But the value that we get is 0.0077. So the compression reinforcement is not required because the K that we get is less than K balance, which is 0.167. So the Z value that we get is 0.99D, which is also more than 0.95D, the original value. So we should use the original value to find out the Z, 0.95 times 0.95D times with 110. So you will get the Z as a 105 mm. Okay, the next is AS. The value of AS is 61 millimeter power of 2 per m. So it is still affordable, which is the section that we use is 196. So it still can be used and have more space, and also can use as a 166 millimeter power of 2. Okay, the next is support. MSY equal to 3.71. The K value that we get is 0.010, which is less than the original K balance 0.167. So the compression is not required. because the K that we get is 0.010 is less than the original K balance value 0.167. Okay, the Z is that we get is 0.990. As usual, as same that the original is 0.95. It is more than the original, but we should need to use the original Z value, which is 0.95t times heat 110 105 millimeter. So the AS is equal to 81 millimeter power of 2 per m. Okay, now I'm moving to the shear force and shear sections. Okay, for the short span, which is Vxx1 equal to 0.33 times 12.89 times 3.0 equal to 12.76 kilonewton per meter. And also for the short span also we need to find the VSX 2 equal to 0.33 times 12.89 times 3.0 equal to 12.76 kilonewton per meter. Okay, for the long span, we should find also as same as a short span, which is VSY1 equal to 0.33 times 12.89 times 3.0 equal to 12.76 kilonewton per meter, and also VSY2 equal to 0.33 times 12.89 times 3.0 equal to 12.76 kilonewton per meter. Okay, for the design shear force, the total VED we get is 12.76 kilonewton. Okay, the next step is we should find the design shear resistance. The formula that we are going to use is VRDC bracket 0.12 K bracket 100 T1 FCK close bracket power of 1 per 3 close bracket PD. So the first is we should find the K, which is 1 plus the formula that we are going to use to find the K is 1 plus bracket 200 divided by 3 close bracket power of 1 per 2. The value is must be less than 2.0. Okay, so the final answer that we get is 2.35, which is more than the original required value is 2.0. So the P1 that we are going to find is AS1 divided by BD. The last answer, which is the last value, is must be less than 0.02. So the P1 that we get is 0.0016, and it is also still less than the original value 0.02. Okay, now I'm moving to the next step, which is VRDC to find out the VRDC. So we already have the before solution values, so you can replace into the formula and you will get the VRDC is as a 44533 Newton, and we can let this final answer in unit of N, so we should convert it as a kilonewton, so you will get as a 44.5 kilonewton. So the V mean that we get is 596.44 newtons, as same as a VRDC. We cannot let the final answer as a unit as a newton, so we should convert it as a kilonewton, which is 59.6 kilonewton. So the VRDC is equal to 59.6 kilonewton is big than the VED 12.76 kilonewton, so it is considered okay. Okay, now I'm moving for the deflection. Percentage of the required tensile reinforcement is P equal to AS request divided by BD. So AS the requested that we get is 166. So the BD is 1000 and the D is 110. So once you get the values, you should replace in the formula and you will get an answer as a 0.0015. And the reference reinforcement ratio is PO. Okay, the unit that we are going to use is PO. The formula is bracket FCK power of 1 per 2 times 10 power of -3. So the FCK that we already get in information as a 30. So for the factor for structure system, K is equal to 1.3, and then the value that we get is 0.005. So here we can conclude is P is less than PO, so we can use the equation 1. So they are the equation. Okay, so the answer that the final answer that we will get as a 131.12. So the modification factor for span must be less than 7 meter. So modification factor for steel is area provided, which is we are going to find as a area provided as requested is equal to 196 divided by 166, must be less than 1.5. So the value that we get is 1.2, which is less than 1.5. The next is therefore the allowable span effective depth ratio is 157.34, and also the effective depth, which is actual span that we get, is 27.27. So here we can conclude as the actual is less than the allowable. So it is considered okay, and the cracking is h equal to 150 millimeter is less than 200 millimeter. So the main bar is S max slab is equal to 3h less than 400 m, and 3 times 150. The S max slab is you will get as a 400 millimeter. So maximum bar spacing is equal to 400 millimeter is less than S max slab. Secondary bar, which is S max slab, also we should find, we will get as 450 millimeter. So here you can calculate as a maximum bar spacing is equal to 450 millimeter less than S max slab. Okay, so this is the last step for this question, which is detailing. So you can refer, this is the detailing that we draw from the information that get from the previous calculations. Okay, now I'm going to explain about the column section, which is determination of slender or non-slender. Okay, the drawing is shows the value with which is FCK is equal to 30 Newton per mm power of 2, and FYCK that we get is 500 Newton per mm power of 2. So the dimensions and sizes, the column for the dimension size is B is 250, and also the H is 250. So Ix is equal to 4000 minus 650, that you will get as a value as 3350 millimeter, and the Ly is 4000 minus 650, and also same as a value that Ix you will get as a 3350 millimeter. For the beam, which is main beam, is you should find Li is 250 times 650 millimeters, so you will get a L1 as a value of 6400, and also the L2 as a 4000 millimeter. For the secondary beam, which is L1, you will get as a 6200 millimeter, and for the L2 you will get the value as a 1800 millimeter. Okay, the next is I'm going to explain about the moment of inertia, which is the formula of I equal to B h power of 3 per 12. Okay, column, for the column is IZZ is equal to 250 times 250 power of 3 divided by 12. So you will get a value of 0.33 times 10 power of 9 mm power of 4. So for the IYY is equal to 250 times 250 power of 3 divided by 12 equal to 0.33 times 10 power of 9 mm power of 4. For the beam is main beam, which is I is equal to 250 times 650 power of 3 divided by 12, you will get a value of 5.72 times 10 power of 9 millimeter power of 4. For the KYY is you will get as okay, for the second beam, which is I is equal to 250 times 650 power of 3 divided by 12, you will get as a value of 5.72 as the same as a main beam. For the column, which is KZZ, you will get a value of 0.99 times 10 power of 5 millimeter power of 4, and also for the column, which is KYY, you will get a value as a 0.99 times 10 power of 5 mm power of 4. Okay, for the beam, okay, for the beam, so for the main beam is the value of you will get for the KMB1 is equal to 8.94 times 10 5 mm power of 4. And for the KMB2 you will get a value of 1.43 times 10 power of 6 mm power of 4. For the secondary beam you will get as a KSB1 is equal to 9.23 times 10 power of 5 mm power of 4, and for the KSB2 you will get as a 3.18 times 10 power of 6 mm power of 4. Okay, now moving for the relative column stiffness, which is K equal to K equal. Okay, the Z axis for the top end, the K2, that the value that we'll get is 0.02, which is it is less than 0.1, so you should use 0.1 value. For the bottom end, which is K1, the value that you get is 0.02, which is less than 0.01, and still you should need to use the 0.1 value. And also for the y-axis, the top end, which is K2, the value that you get is 0.01, which is also less than 0.1, so you should use 0.1 value. And for the K1 for the K1, so the K1 that you will need to use this formula and you will get an answer. It is also less than 0.1, so you need to use the value of 0.1. Okay, now I'm moving to the effective length of column, which is we are going to use the formula of IO 0.5L puncture cos over bracket 1 plus K1 divided by 0.45 plus K1 close bracket open bracket 1 plus K2 divided by 0.5 plus K2 and close bracket. So the IOZ that we will get is 0.59191 times 3350 equal to 1980 millimeter. And also the IOY that we are going to get is 0.591 times 3350 equal to 1980 millimeter. Okay, for the radius, the formula that we are going to use is I divided by A with power of 1 per 2. So the IZ that we will get is 72.66 millimeter, and also same as IY, which is 72.66 millimeter. For the cylinder ratio, for the Z cylinder ratio that we will get is 1980 divided by 72.66. So the answer that you will get is 27.25, and for the cylinder ratio for the Y is you will get as the same value as Z, which is 27.25. For the cylinder limit, which is for Z axis, for C2 you will get as a 3.06, and also M is equal to negative 1.36, and for the Y axis the CY that you will get is 2.64. okay, for the next step is we should find the N, which is the formula is NED divided by bracket AC RCD. So where the AC is 250 times 250 equal to 0.63 times 10 power of 5 millimeter power of 4. So for the RCD, the formula that you are going to use is 0.85 FCK divided by lambda C. So the final answer N, which is you will get as a 1.15. Okay, the next is I'm going to explain about the x-axis, z-axis, which is you will get as a 43.94, which is less than 27.25, and also for the y-axis is you will get as a 37.91, is also more than 27.25. Okay, the next is we are going to do about the design of non-cylinder column about both axes. Okay, for the classification, the material, the concrete that we used is FCK, which is 30, and also FYK is 500, and size of B and H is 250 times 250, and the effective length is IOZ is equal to 198, and also IOY is equal to 198, and also cylinder ratio that we already counted the before step, which is 27.25, and also the cylinder ratio of Y is for 27.25. Okay, assume the link is equal to 6 millimeter, and also bar as a 20 millimeter. So this is the drawing of the classification and also design for the column. About the size is the axial force is 1243 kilonewton, and also the bending moment, which is MZ, is equal to 5.09 kilonewton meter, and also My is equal to 0.89 kilonewton meter. Okay, for the durability and boil fire resistant, you can use CNOM as a 35 millimeter, which is C min is equal to 25 and also C def is equal to 10, and we should plus the both of them as 25 plus 10 is equal to 35 millimeter. So that is our C norm that we are going to use for the whole calculation. Okay, for the design movement, the imperfection of movement is MSP1 is you will get IO1400. For the MSP2 is you will get as a 0.15 kilonewton meter, and also same as a MSMPY you will get as a 6.15 kilonewton meter. For the design movement, which is including the effect of imperfection, for the MEDZ you will get as 11.24 kilonewton meter, and also MEDY you will get as a 12.04 kilonewton meter. Check the biaxial bending. So for the EZ you will get as a 10.49 millimeter, and also EY you will get as a 9.04 millimeter. Okay, for the check biaxial bending. Okay, first you will get as a 0.86, which is more than 0.2, and also the second EZ per B times with EY per Y. So the value that you will get is 1.16, which is also more than 0.2. For the next is ignore the biaxial bending. Okay, for the first is you will get as a 1, which is also less than 2, and the second for the Z and Y is you will also get as a 1 less than 2. Okay, for the reinforcement concrete, to find out the H, 250 minus 35 minus 6 minus 0.5 times with 20, you will get as a 234 millimeter, and for the B you will need to 250 minus 335 6 minus 0.5 bracket 20 equal to 234 millimeter 2. For the MZ per H, you will get as a 48.03 kilonewton, and also MYB you will get as a 53.73 kilonewton. Okay, that's all from this part. Okay, I'm moving for the next part, which is MY. For the MY you will get a value of 16.86 kilonewton meter, and also for the MZ you will get as a 15.67 kilometer. To find out the D2 value, you should need to use C plus bar link plus and 0.5 bar, which is equal to 35 plus 6 plus 0.5 bracket 20, which is you will get as equal 51 mm, and the D2 per H value you will get as a 0.204, and you can take a 2 decimal place and you can use as a 0.20. Okay, for the N per BHFCK value you will get as a 0.66, and also N per BH2FCK you will get a value of 0.04. Okay, for the AS FYK divided by BHFCK you will get a value of 0.25. So for the AS you will get as a you will get as a 937.5 millimeter power of 2. So you can use 4H20 and also 2H16, and you will get a value of the total value of 1659 millimeter power of 2, and it's still affordable also. So for the AS mean is the value of AS mean is 285.75 millimeter power of 2. And also okay, for the AS max is for the AS max value is 2500. Okay, for the link the SV minimum is the lesser than 2000 lesser than 320 millimeter or 250 millimeter or 400 millimeter. So for this section, for the main section, you need to use a 6 millimeter. So the trial section is H6 to 250. Okay, here we can conclude that at section 300 mm below at above beam and at lap joint SV max, which is equal to 0.6 times 250 equal to 150 mm. So we should use the trial section of H6 to 150 mm. Okay, so this is the check Bayesian bending, which is steel area. A11 is so these are the value that we are going to use for the A11, Z to Z and Y to Y, AZ, AXZ and also ASY. Okay, for the D2Z per H, the value that you will get is 0.204, and also same as a D2Y per B, you will get as a 0.204. Okay, for the N per BHFCK, you will get as the value of 0.66, and also the ASZFYK per BHFCK, you will get a value of 0.44, and for the M per BH power of 2 FCK, you will get a value of 0.09. And moreover, the MRDZ, the value that you will get is 42.19 kilonewton meter. And for the AZYFYK and BH FCK, you will get a value of 0.34, and for the same as a M per BH2 FCK, you will get as a 0.07, and for the MRDY, you will get a value of 32.81 kilonewton meter. Okay, for the NRD, the value of NRD you will get as 1785 kilonewton, and for the NED per NRD you will get a value of 0.696. so you can take 2 decimal places same as the previous step, so you can list your answer as a 0.7. Okay, for the imperfections need only to be taken in one direction where they have the most unfavorable effect. So the MEDZ you will get as 11.34 kilonewton meter, and for MEDY you will get as a value that's 13.05 kilonewton meter. So this is the last step of the question, which is you are going to insert all the value that you get from the previous step, which is open bracket MDZ per MRDZ close bracket power of A plus MEDY divided by MRDY close bracket power of A. The answer must be less than 1.0. So the answer that we get is 0.39, which is less than 1.0. so it's considered, and it can be also concluded as okay. So this is the last step, which is detailing. Is very important for the column question. So that's all from me. Thank you for the time, and see you all in next presentation.